Hello, you're welcome to this tutorial. In this tutorial, we'll be looking at linear inequalities in one variable. So by the end of this video, you should be able to understand what linear inequalities are. You should be able to solve linear inequalities. You will also learn how you can represent the solution of linear inequalities in a line graph. My name is Ademola Folarin. This video is powered by IOTA Virtual Learning. So let's start. When we say linear inequalities, it's similar to our linear equation. In our linear equation, two expressions, we say they are equal to each other. Let's say we have 3x minus 5 is equals to 2x plus 7. This is linear equation. We have two expressions equal to each other. But for linear inequalities, is a way of comparing two algebraic expressions or two terms. So for linear inequalities, we have something as saying 3x minus 5. Rather than having equal sign as in linear equation, we now have inequality sign, such as greater than 2x plus 7. It can be less than, it can be greater than or equal to, it can be less than or equal to. But linear inequalities involve comparing two algebraic expressions using inequality sign. So when we compare two terms using inequality sign, we are dealing with linear inequality, such as we say 2x is less than or equals to 10. This is linear inequality. Here we are focusing on one variable. So remember our inequality sign right from our basic mathematics days: greater than, less than, greater than or equal to, less than or equal to. Now we understand the concept of linear inequality. We can then proceed to solving problems involving linear inequalities. How then do we solve problems in linear inequalities? So simple, just as the way we solve problems in our linear equation. However, here in linear inequalities, whenever we divide both sides or multiply both sides of the inequalities by a negative number, the inequality sign will change. Whenever we divide or multiply both sides of the inequality by a negative number, the inequality sign will change. That is, it will flip to the other side. So let's take one example for a start. Here we have solve the inequality 7x plus 4 less than 1 over 2 open bracket 4x plus 3. So to do this, we have 7x plus 4 less than 1 over 2 open bracket 4x plus 3. Just as the way we solve our linear equation. This is 7x plus 4, which can be assumed to be divided by 1. And here we have 4x plus 3, which we can say is being divided by 2 based on the coefficient that we have here. So the very first thing is, we want to say we cross multiply or we multiply both sides by 2. So multiply both sides by 2. when we multiply both sides by 2, this side becomes 2 open bracket 7x plus 4 close bracket less than 2 multiplied by 1 over 2 open bracket 4x plus 3. And when we do this, this becomes 14x plus 8 less than, these 2 cancel out with these 2, 4x plus 3. Here now, what we then do is collect like terms. We collect like terms. That is, we bring the x to one side, we bring the natural number to the other side, which is 14x minus 4x less than 3 minus 8. This gives us 10x less than minus 5. So here we have to divide both sides by the coefficient of x, which is 10. That means it becomes 10x divided by 10 is less than minus 5 divided by 10. X is then less than minus 1 over 2. So what this means is that for this given question, the value of x that satisfies this must be less than negative 1 over 2. It must be less than negative 1 over 2. If you put negative 1 over 2 in this inequality, it will not be satisfied. So for the value of x to satisfy it, that value of x must be less than negative 1 over 2. So we can think of values that are less than negative 1 over 2. Those are the values that can satisfy the given inequality. Isn't that interesting? Oh, fantastic. So let's take it further. Let's try another problem. We have this. So here the question is asking us to solve the following inequalities and represent them on a line graph. This is greater than or equals to. So we are solving this inequality and we are representing the solution on a line graph. That's another interesting part that we must learn. To make it easy, let me start by dividing my space. Alright. So number 1, 3 open bracket x minus 5 less than 6. What we need to do is open the bracket 3x minus 15 less than 6. Collect like terms. That will give us 3x less than 6 plus 15, giving us 3x less than 21. Divide both sides by 3. That gives us x less than 21 over 3, and that says x less than 7. What does this mean? It means the value of x that can satisfy this inequality must be less than 7, which means the value of x will be 6, 5, 3, 4, 2, 1 downward for this inequality to be satisfied. Unlike linear equation where x will be said to be equals to 7 and no other value can satisfy it. But in inequality, it means the values that can satisfy this must be less than 7. So let's put this solution on a number line. Let's try to sketch out this. This one is telling us that the value of x is less than 7. So if this is 0, this is the graph of x. This is 7. Let's say minus 7. So here it means we are going to use this arrow to tell us that this value is less than 7. So x will take any value that is less than 7. We just put it there. X is less than 7. The direction of this arrow shows us the direction of those values that can satisfy the statement. Isn't that interesting? Fantastic. So let's take the second problem where we say 2 open bracket x minus 3 greater than or equals to negative 2 open bracket 3 minus 4x. Here we try to open the bracket. It becomes 2x minus 6 greater than or equals to, we open this, which is going to give us minus 6 plus 8x. The next thing for us to do here is to collect like times. Collect like times. That is, take the terms involving x to one side of the inequality. Take the terms involving number to other side of inequality. And here it becomes 2x minus 8x is greater than or equals to minus 6 plus 6. And we will have negative 6x is greater than or equals to 0. So here we want to divide both sides by negative 6. Remember, in inequality, when you divide both sides of the inequalities by negative number, the sign will change. So we then have x less than or equals to 0 divided by negative 6. And remember, when you divide 0 by any number, x will be less than or equals to 0. What this solution implies is that the value of x that can satisfy this inequality must either be equals to 0 or less than 0. So any value of x above 0 cannot satisfy this condition. That is, cannot satisfy this inequality. That's what that means. Then how can we put that on a number line? Let's have our number line here. So to put that on a number line, let's say this is 0, x, this is positive side of it, and this is the negative side of it. So since the value of x must be from 0, let's say we have a negative 5 downward and positive 5. The value of x must start from 0. We call that inclusive inequality. Less than, because it's inclusive, we have to shade this part. unlike the other one here that is not inclusive. So whenever we are representing something of less than or equals to on a number line, it follows this pattern. Inclusive, this place is shaded. If it is greater than or equals to, it is done this way. This is shaded. If it is just ordinary less than, it is done this way without shading it. If it is ordinary greater than, it is done this way without shading it. So that tells you the direction in which the number line graph will go whenever we have any of these as our solution. It's beautiful, yes. So let's look at another question, probably a WAEC question, yes. Okay, this is a WAEC question, year 2015. The question says, solve the inequality 4 plus 3 over 4, open bracket, x plus 2, less than or equals to 3 over 8x plus 1. Now, let's start. We are just to solve this. This is a very common question when it comes to WAEC, NECO, IGCSE. We approach it the same way we approach our linear equation. We must just take into consideration that if we need to divide both terms, both left hand side and right hand side of the inequality, if we are dividing it by negative number, the inequality sign will flip, that is, will change. So let's solve this. 4 plus 3 over 4, open bracket, x plus 2, less than or equal to 3 over 8x plus 1. In doing this, we approach it the regular way we approach equation. So let's look at this. Here, the denominator here, the maximum denominator at the left hand side is 4. The maximum denominator at the right hand side is 8. Can we find the LCM of 4 and 8? Yes, that will give us 8. Now the best thing is to then multiply this 8 by both sides. That is, multiply through by 8. Multiply through by 8. So if we do so, it becomes 8 times 4 plus 8 multiplied by 3 over 4, open bracket, x plus 2, close bracket, less than or equals to 8 multiplied by 3 over 8x plus 8 multiplied by 1. So we've multiplied each term through by 8. So multiplying 8 by 4, what does that give us? That gives us 32. So here we have 32 plus, when you multiply this, 4 goes here 1, 4 goes here 2. Then we use that 2 to multiply 3. That's 6, open bracket, x plus 2, less than or equals to, the 8 here can cut this 8. That gives us 3x plus 8 multiplied by 1, that's 8. Now we have to open this bracket. It becomes 32 plus 6x plus 12 less than or equals to 3x plus 8. The next thing for us is to collect like times. Collect like times. Those with x, let them come to the left hand side, while those without x, let them go to the right hand side. This becomes 6x minus 3x less than or equals to 8 minus 12 minus 32. So this gives us 3x less than or equals to, when you subtract 12 from 8, you get negative 4. Negative 4 plus negative 32, that's negative 36. So we then divide both sides by the coefficient of x, which is 3. That becomes x less than or equals to negative 36 divided by 3. So doing that, x will be less than or equals to negative 12. X is less than or equals to negative 12. What does this mean? It means for this inequality, the range of value of x that satisfy this inequality above will be from negative 12 down to negative 11, negative 13, because they are dealing with figures that are less than negative 12. So we are considering figures that are less than negative 12. Negative 12 itself is inclusive because of equals to, then negative 13, negative 14, negative 15. So these are values that are less than negative 12 and so on. Remember, negative 12 will be included because this less than or equals to shows that negative 12 can be the value of x or any value less than negative 12. So I think we've been able to do justice to the concept of linear inequalities in this first series of this video. So be on a lookout for the series 2, where we'll be looking at linear inequalities in two variables. If you enjoyed this, don't forget to like this video, share, and subscribe to our channel. Thank you.